This is Justin Schaefer. He is the Coastal Resilience Manager with the City of Norfolk Office of Resilience. He's got a master's in biology from ODU. His career is focused on the study, protection, and restoration of coastal ecosystems and the management of water in coastal urban settings. In his current role, he oversees environmental analysis and nature-based feature restoration associated with coastal storm risk management flood protection project. That he supports social, economic, and environmental resilience initiatives. He continues to regularly advise on water quality improvement programs, apply for grant funding, coordinate various departments and community partners in the implementation of green infrastructure projects. In short, there's no better person in Norfolk to lead this class than Justin Schaefer.
Morning, everybody. Sorry I'm a little late, hit some traffic, but glad to be here with you all today. I'm getting over a little bit of cold or allergies. I'm not sure which. Maybe it's Bradford pears, both of them. Come on down. Yeah, happy to be here this morning to talk to you a little bit about wetlands and coastal shoreline systems. We're going to take a bit of a walking tour first, talk about some of the plant species, a little bit about some of our restoration efforts here at the Hermitage and around it, and then we'll go inside and talk a little more about benefits of shorelines and how we go about restoring them and maintaining them here in Norfolk. Sound good?
Yeah.
Okay. Well, I think we always start off out here by the road because that's our big restoration project there. So we're going to take a walk that way. So feel free to intermingle or anybody has any trainees amongst the group. Yeah.
I think we can start.
Okay.
Yeah.
Okay. Again, good morning. So this is the Hermitage East North Shore Road living shoreline. I like to start here because obviously nice view. Okay, got the sun in our eyes here for a few minutes, but I'm gonna go on up. And it's just a really good example of what we try to do in Norfolk when we're looking at shoreline restoration. So when you're thinking about a tidal marsh here in the kind of coastal plain, you're thinking about a system it's a salt marsh. So the tide comes in and out on it every day. About halfway up, tide goes regularly, and then that determines one part of the marsh. And then on the moon tides, when you have a full moon or new moon, tide goes higher, right? And so that creates more wetlands. So there's different zones. We'll talk about that in a minute. Historically, these systems are everywhere in Norfolk where you see a ditch or a little creek. Envision the land not being quite as high near that and sloping back much more gradually. These systems flow throughout our city, throughout Norfolk, Virginia Beach, Portsmouth, everywhere down here in the tidewater. Right? You go a little further inland, some of the more rural areas, you'll still see that to an extent. Nice wide, broad wetland systems. But over time, unfortunately, human development, we came in and we started filling more and more. And I have some pictures later I can show you that really demonstrates that. So we want to try to restore these systems to the extent we can because they do provide a lot of benefits. When you have those big, broad wetlands and what we call the floodplain, so the floodplain being the area that the water can flood up onto naturally, that provides a lot of, obviously, habitat. That's where all the critters live. It also provides a lot of flood prevention. So it provides flood storage. It sucks up that water, holds onto it. It provides erosion control. So there's nice, gentle slopes all the way down into the river bottoms, sloping up gently. That provides erosion control. So as bigger rivers meet those waters, it slows down the flow. As waves come in off the ocean or off the bays, slows down the wave action. And then it provides a lot of water quality benefits. So it treats any chemicals that are in the water. And obviously, historically, those chemicals were natural. So it was just byproducts of waste from animals, just natural cycles. Of course, we generate a lot more pollutants of all kinds now, fertilizers, chemicals of all sorts that we use in different processes. More concentrated waste, whether human waste, unfortunately, more rural areas where you don't have good sanitary systems or just animal pet waste. And so wetlands are important to provide that filtration still, even at their reduced capacity. but we want to, in a place like Norfolk, where historically we filled probably 90% of our wetlands here, if not more. We wanted to find ways to start restoring them to get some of those benefits back. And so a lot of this was triggered. It started probably about 20 years ago, some smaller actions, some different groups that started promoting this, like Elizabeth River Project, Chesapeake Bay Foundation, some folks at ODU. The city got more involved over time, and then there were some regulatory reasons that we started doing it. We have options for what we can do, and so we said, all right, wetlands are a good thing to do, so we're going to choose that as one of our main ways to meet some of our regulatory water quality goals. So there are different reasons that we restore wetlands. But when I'm thinking about a wetland, we call them living shorelines, and a living shoreline is more of a engineering type term. Although the engineers will say we don't have enough specifications for it, so I'll show you a little more about that later. But in reality, living shoreline is not a natural shoreline. So a natural shoreline, it's a wetland. Okay, it's a marsh, tidal marsh. So if you hear somebody say a living shoreline, they're generally referring to something that somebody's restored, that they built, created, restored, maybe enhanced significantly. And so when we're looking at doing that, we want to think about the whole system. So if you envision yourself here hundreds of years ago, these houses wouldn't be here. These exact pine trees wouldn't be here, but there would be a lot of big pine trees like this behind us. All right. Loblolly pines and longleaf pines, which are much less common in this area now. We try to do some restoration, and if some of you've worked on that over the years, would have been in significant numbers throughout this. And it would be as you approach the shoreline, you get away from the upland forests, which were more oak and hickory dominant. Get closer to the shore, they're going to be more pine dominant, with some other species we can talk about as we get into the Hermitage here, because it's a good site to see all of this. You have these big pine trees with a lot of native grasses, things like our, I stepped down, popped out the one so we could see a little better, but the switch grasses would be growing significantly. Your dewey grass, little blue stem, big blue stem, okay, andropogons. So a lot of grass species, and obviously a lot of shrub species as well, but wouldn't be dense dark forest like you might see up as you get into the mountains. Be kind of more wide open, not quite savanna, but trees with sight lines. Then as you get closer to the water, you get into saltbush. So you can see the big tall green, very green, they're evergreen shrubs. That's Baccharis similifolia. Saltbush, there's another species that's also called saltbush, Iva frutescens. They grow very similar locations. I think we have some examples down here. I can show you exactly where to help you identify. But you get into, just like on any woodland area, when you get to the edge, you get a bit of a jungle effect. So you get the light penetrating, so you get more dense plant growth. And very commonly in the coastal plain, it's going to be the species of saltbush that are growing there. And then that transitions down into, again, more grasses, some coastal wildflowers like goldenrod that grow regularly along the coast, and then into the true marsh. But everything I've described so far, up to a point in that pine forest, is the floodplain. So it's where during a big hurricane or nor'easter storm, all that water would have flooded up into that and not bothered anything. Of course, now all that water floods up here and it does bother things. It bothers us. Bothers our houses, our cars, our infrastructure. So the wetland, we often break the wetland into two zones: the high marsh and the low marsh. Let me start at the bottom. So the low marsh is defined as the area that is inundated daily. And here in southeastern Virginia, our low marshes are dominated by Spartina alterniflora. All right, so you hear the term Spartina a lot. It's used generally. There are two commonly used species of Spartina. There's actually three that are native to this area. So Spartina alterniflora is, as you look out, sorry, you can't see too well, but as you look out, you'll see closer to the rocks along the water, there's some higher plants that grow up. All right, so that's the Spartina alterniflora. It grows up higher, more stiff. And the reason it does that, and you can see it on either side, you might be able to see a little longer down this way, Sorry, my crews didn't get out here and mow down the buffer along the marsh yet. We do it annually to keep the pine trees from growing in, blocking the view. So it's sort of a management approach here in the urban area. But the alternate flora stays more upright. It's a little stiffer stems because it takes that wave action. Right, the waves are impacting it. And so it's an adaptation. It's more stiff so that it doesn't break. So it can still photosynthesize, stays above the water easier. And then it helps us by blocking some of those waves as they come in. As you move back further into the marsh, you'll see some of the grasses that are more wispy, kind of laid over. That's Spartina patens, salt meadow hay. And, historically, you might have seen acres of that, wide swaths of that flopped over like that. And it literally was used for forage for animals and things in some coastal settings and a lot of other materials. So that's higher. It's not quite as stiff, a little more wispy. So that's a good way to differentiate between the two. But the high marsh where the Spartina patens primarily grows, that area is inundated on a monthly basis. So that's where at least maybe, let's say, a month out of the year, because of the tide cycles, that area gets overwashed for a couple of days in a row. And then for a week or so, it doesn't get much water, except maybe during a storm. And then the next quarter of the month, it gets washed up on more. So it's too salty for Bermuda grass to grow. It's too salty for most of our landscape plants to grow. But Spartina patens is adapted to it. And as you get a little further to the upper end of the high marsh, you get into a lot of other diversity of species. So you get into things like marsh hibiscus. You get into coastal hibiscus, coastal lexia. You get into some of your goldenrods that can handle that higher water level, as well as some other grasses like little blue stem that can handle a little bit of salt marsh. And so you just start to develop a gradient as you move between the high marsh, the lower end of the high marsh, into the kind of the upper high marsh, and then eventually into the shrub zone and into the forest. And there's a variety of species that will grow in there. Barricchia frutescens, nice little sunflower, small sunflower that we use. If you're in more of a beach type setting, you'll see yarrow a lot of times, which you all are probably familiar with from a landscape setting. So start to get a little more flowering. Okay, but even the grasses, I was like, you get a lot of, as you really look at them, you get a lot of diversity of color in those too, just different greens and browns and grays different times of year. So. Some people don't love to look at them. This guy right here that's attacking me, a mixture of some kind of a pea vine, I think. This is dog fennel, which not too many people like. Residents don't particularly like the look of it. They tell me regularly that it's getting a little tall down there, and they'd like me to get rid of it. But it's native, Eupatorium folium. It's good native plant. But yeah, it's not the prettiest. It is unfortunately a plant that is very adaptive to cutover areas. It's a early successional species. So any field that you've ever created by cutting down a forest or plowing over a field, you're going to have dog fennel growing in this part of the country. So it's aggressive. It will take over. So it's a good example. This area, kind of shifting over to the restoration side of things. This area was just rock. So about a decade ago, you would have stepped off this curb, walked about where I am, and then it would have been rock sloping down to the water, a riprap or revetment. And so, some of the residents here like that. They weren't happy to see that go away. They just like the clean look of it. It's like a lot of people like bulkheads and riprap revetments in their backyard over a more natural solution. Eye of the beholder. But it was an area that some of that rock was getting undermined. We obviously have a pretty busy road here for the neighborhood, and a couple good hurricanes or nor'easters, and where those rocks were getting undermined. Next thing you know, your sidewalk's going, big enough storm, then your road's going, and then the residents are more upset about things that are a lot more expensive for us to fix. So this is a site we identified due to infrastructure issues for a living shoreline, and obviously it was a nice big site. We had a willing partner at the Hermitage, Phil. A little before your time, but you've been helping us maintain it here. To do a nice big restoration. You can see it wraps on down past the point down there where you can see the rocks extending. So when we do these restorations, we want to mimic as much of that system as we can for any given location. So we start with the offshore section. I didn't get down to the offshore, so let me finish up with that zonation. So we talked about the low marsh, the high marsh, the buffer zone, then getting into the coastal forest here. When you get down to the bottom half of the low marsh, it's actually mud flats. So it's the intertidal zone, but there's no longer a marsh because the grasses are adapted to a certain amount of water. So if it gets covered too much of the day, then the Spartina alterniflora, which is happy being drowned most of the day, will die. So that's particularly critical as we start thinking about sea level rise, because it's happy being drowned for 75% of the day, but not 80% of the day, probably not even 77% of the day. So it will die, and it will die quickly, and then that causes more erosion issues, and we start to lose the benefits of the shoreline. So when you get past that, then slopes down to mud flats, and then offshore of that, historically in the Lafayette River, you would have had a combination of some soft bottom, some seagrasses, which we definitely do not have here anymore. It's a little too polluted, a little too turbid. It's getting better, but we're not quite back to seagrass level yet. And oysters, which we have been very successful on restoring. The Lafayette River is the first tributary in the state of Virginia to be restored to the Chesapeake Bay program standards for oyster restoration. So we've restored with partners from the Army Corps, the Port, or Chesapeake Bay Foundation, the Elizabeth River Project, many others, including the city. We've restored a couple hundred acres of oyster reef out here in the Lafayette and preserved many acres more that were historically there. We have oysters that are this big out here, just past the bridge out there in the old channel, where they were never poached or harvested by anybody. So big oysters. We have video of them. So when we're thinking about these designs, we want to think about that full continuum of ecosystem and how we can best restore it for the given site. So at a site like this, we have a decent fetch. Not terrible. It's not a direction where we're getting constant wind, but when wind blows in here, if you come by here on a windy day, there's waves. All right, so water's moving. The fetch, good question. I'll show you a diagram of it later. But the fetch is the distance that wind can travel from one point of land to another, which is what generates wave action. So if you're just going, the wind is blocked there by that house, then to get here, it's not much. You can't generate many waves. But if it's all the way open a mile that way, you can generate a lot more wave action when the wind is blowing in that direction. So, like I said, I have a picture I can show you inside to demonstrate that. So we put what we call a rock sill. So the rocks that we have out here are a sill, S-I-L-L is the term. And what that is, it serves a couple of purposes. One, it creates, probably most importantly, it creates a place for us to start our marsh. And the reason we can't just, so we're building these marshes by dumping sand out there, placing sand. And if you can imagine, if anybody out here has walked in the Lafayette River before, if you just drop sand, it's going to flush right out into the river, and or it's going to sink. Okay, some combination of those two. So we need something to tow that sand in, so that it holds in place as best as we can get it to. So we place the rock sill at the distance offshore that seems appropriate based off the tides. We don't want to go too far out, because then we're covering up what was historically river bottom. And in most situations, we don't want to cover up river bottom. River bottom, whether it's got oysters on it, historically with seagrasses, or if it's just bare bottom or clamshell, there's a lot of stuff that lives in all those different habitats, and they're very productive. They have big carbon cycle, nutrient uptake, lots of little worms and critters and crabs living in them. So the fish like to swim along and eat all that stuff. So we want to maintain that sort of habitat too. So we don't want to push too far out. We also have equipment. We can only go so far with our equipment before we have to bring a barge in and start doing the work, and that just pushes the price up. So we want to avoid that. So we place the rock, that spreads weight, and then we place the sand, and then we can come in with the plants. The rock provides the habitat for the oysters. So We know that seagrass won't work here, so we're not worried about putting sand out on the bottom to grow seagrass like they might. They're starting to do in the Lynnhaven River. They've got a little less turbidity there, and up on the eastern shore in a lot of places where seagrass, they're starting to bring it back. So we focus on oysters because we know oysters are happy here in the Lafayette. It's one of the most productive rivers for oysters in the state. They just put out baby oysters all day long in their growing season. So you can see as you look out here, you can actually see the tide's perfect right now, but you can see the oysters growing up above the mud line, growing off in front of the rocks. All those little specks that are out there, you can see along the rocks. That's all oysters. And when they first start growing, they're just these little microscopic dots, and then they grow. They create shell. That shell every year gets bigger and bigger, and then more little baby oysters grow on that shell, and then they grow out, and it creates a three-dimensional reef. Which historically, you hear the maybe tall tales, maybe true, but the original settlers that came up the oyster reefs, the bottom of the boats were hitting them. They were so high up in the river, 20-foot tall oyster reefs. We're not going to get back to that anytime soon. Okay, but every little bit helps. Again, that provides more filtration. Oysters are great filters. More habitat, just more barnacles live in them, little worms live in them. The fish eat those. Food cycle. It helps with that ecosystem service. So by using the rocks like that in an area where the oysters are prone to set, we've created that offshore habitat. We've then restored the marsh. We try to plant grasses and some of the shrubs come in on their own, even if we don't want them to. Other things come in that we don't want them to. So I'd say from a restoration perspective, this buffer zone appears the most contentious. People are generally happy to see the pretty marsh out there. They're not so happy to see the dog fennel, as we discussed. Some people just hate goldenrod because they believe that it causes their allergies every year, because that's what they were always told. But growing out, usually the dog sometimes depends on your allergies. But there's other things moving at the same time. And if we let it, ecological succession keeps occurring. If we let this is going to turn back into a pine forest right up to the water almost, with some of those shrubs along the edge, just like it would have been historically. So we do come in once a year in the winter. Once the sort of winter critters have finished using it for cover, we'll come in and brush mow all of this down to like 6 inches. Hopefully not brush mow our property next door illegally. I did that last year.
Do not mow.
Bill's going to stay out here and watch for it.
Why would you not want it to turn back into that was the original state? Is it just for us, for view wise?
Because we're in an urban context here.
Okay.
So if I was doing this restoration on the eastern shore on a barrier island, or along a farm up on the Middle Peninsula, absolutely, we would plant the trees, restore it as much as we possibly could. But when you're working in an urban setting, you have to think about everybody who uses the site, including property owners who've had these view sheds for a long time, people who live in the neighborhood who walk along here and want to see the water. And that doesn't matter what neighborhood I'm in. I could be in Villa Heights and Lindenwood, Parade Park, on a less well-off part of the city, and we still think those same things through, because those residents have the same concerns. And so, we maintain all of our shorelines like that. We brush mow once a winter. Most of the material gets chopped up or left behind. We do haul some of the bigger stuff out. But that keeps the pine trees from getting, about any bigger than that. Keeps the salt bush from getting that tall down here. We let some of it stay off to the side. And it keeps this stuff from, it still grows tall. So one day I'll probably come out here and use some herbicide on some dog fennel, but that's not my specialty, so somebody else is going to figure that out.
How does the rock go beyond the low water?
It's like a little teepee. So the rock just kind of does this. We work with different designs that, sometimes they're a little taller if you have an area with a lot of wind coming at it. And sometimes they're a little lower if it's a real gentle area. It's just like a little bump out there. But the whole rock still is probably no more than 10 foot wide under the water there. So just from one end to the other. And part of that's covered by sand, because the sand keys down into it.
Can the pine trees live in the high marsh and the low marsh too, or?
The pine trees will stop right at the edge of the high marsh. Loblolly pine, which these are, they are salt tolerant to a point, but not enough to get inundated every month. Right? They get inundated during a storm. Probably some of the most salt tolerant trees we have are eastern red cedar. They're very salt tolerant. Some of them in here, actually, you can see some off in the distance there at the end of the point. Some eastern red cedar down there, and those can handle being right up in the high marsh. Like I said, the salt bushes. You get things like yucca, things you think about like the beach. So think about things that can get overwashed regularly at the beach. A lot of those can handle growing along here. They're not the most common thing you see, especially here. But as you go a little further south, you'll see those more and more. And there's some species that aren't necessarily the most frequent historically, but that are well adapted. So hackberry, or probably more commonly around here natively would be sugarberry, which is, you can't even tell the difference unless you're really into your hackberries.
We know, Justin. We know the difference.
You can tell the difference.
Yes, yes.
Sugarberry then is very well adapted to salt. So in its native sort of habitat, it doesn't necessarily grow right along the river, but it'll be the last thing standing out here. It'll be covered by water every day and still has a couple of roots going back the other way, and that thing will still be growing until it literally falls down just from being undermined. So it's that's something we see a lot. Black cherry is another one that seems to do pretty well right along the water. Very common here. So we'll see some more of those as we walk inside. So I think we'll probably wander on through and over towards that point. But any other questions for right here?
Down the hill, any other vintage?
We keep an eye on the rock sill every now and then. If a boat hits it, we might have to go out there and do some work. There's some outfalls down this way where the pipes come out. The design didn't work out very well here. We tried to build big settling basins, and those just keep getting filled up with sand. So probably going to blow those out and just run a rock channel out to the river. So we got to make sure the outfalls can still let water out, and also we have valves at the end. We got to make sure those get closed so the flood water doesn't go back up into the street. So. No, they're very low maintenance. Much lower maintenance than, say, a bulkhead or a concrete seawall. Maybe you've been down to the Price store recently. You've probably seen the seawall down there again that is now in the water. So granted, it's an old seawall, but the shoreline would last a lot longer there if they'd done that instead. So it's a relatively low maintenance option for shoreline areas, and we're increasingly finding ways to do them in higher wave impact areas.
So is the saltiness here about the same as out in the Hampton Roads and the Chesapeake Bay and not the ocean?
Yeah, it is. This gets flushed very heavily every day because you think the James River, right? The Hampton Roads, that congregation of all the rivers, is really right there. So this is just as salty. Now, as you get up towards Tidewater Drive, Lindenwood, Broad Park, Wayne Creek up in Lakewood, those sort of areas. That is definitely the salinity goes down. It still gets flushed every day, but it's definitely less
More fresh water.
What about where the bridge goes over the Lafayette from Chesapeake? Where Chesapeake turns into Lafayette, there's a bridge there. Is that salty?
It is still, again, it gets a little bit less there, but that's still, it's when you really start to get up in these little coves, that's where, you start getting a little less flushing. But right there, we've actually done similar restoration right there. But throughout Norfolk, you're going to find the same species. So the salinity doesn't change to a point where you start shifting over to more freshwater species. So it's still these brackish water species of grasses. And there's some others that grow in here. Black noodle rush is a species of juncus that's salt tolerant that grows sort of in the high, low marsh hybrid area. The third type of Phragmites I'll talk about Phragmites in a minute. The third type of Spartina is Spartina sinusoides, which looks like Phragmites. That's what I was going to say. But that's it's tall cordgrass. It's about this tall, just like Phragmites, and it looks very similar. The flowers are different, the leaves are a little different color, but it actually gets cut down a lot accidentally thinking it's Phragmites. So we have to be careful because there's not a ton of that around. There's a few spots, Poplar Hall, a few spots over on the Eastern Branch where I know there's some growing, but it's much less common here. It's cool when you see it. Other questions?
Is it native?
It is. Yep. Spartina sinusoides is native. It's less common. Other questions? They are. Yep. Boats going by definitely generates lots of small, fast waves, which really causes erosion. Marshes can handle bigger waves actually better. They can handle those little tiny waves that eat away at them. There are some, but most it's loosely enforced. I mean, how often do you see a Coast Guard or harbor police boat out here? It's you know pretty rare, unless there's an incident, then you'll see them. But yeah, just try to raise folks to understand how to be good boaters. But a lot of people out there who are not, sadly. So. Other questions?
Another question. The dog fiddle,
Mhm.
you said it's a native but very aggressive. That would not be considered invasive.
Nope.
That's
No, not it.
non-native.
Not in my kind. The way I speak about invasives is they're truly non-native species. Yeah, I always use the term aggressive native if it's a native plant that just grows wild like this. Yeah, there's lots of them. Because again, it just depends on the context. If this is growing in its native area, it's in a nice prairie or a savanna like under these pines, and it's not bothering anybody, and it's supposed to be there. It's just when you get into a setting where people care about it that it's aggressive. It's all about context. All right, well, let's take a walk on around here. Well, what time are we trying to get inside? Or
Anytime between 9 and 9:30.
okay, all right, we just got some time. Let's walk on around, see some different species. So I always like to stop at this point because we're adding to the erosion problem, but
Yeah.
we won't stand here and tromp along for too long. But the way the Hermitage has left this path, which before this restoration was literally dropping off into the water, but the way they've allowed this path to remain really helps to get you right down at the high marsh, so at the edge of the high marsh, and lets you see as you look along, you can really see that gradation between the low marsh and the high marsh. And there is some intermixing of the two species of the patents and the alternate flora, but but generally speaking, you kind of see it. And when you're seeing where that alternate flora ends, roughly where it ends, if you're looking along a line, that's your high tide line. So if you're trying to figure out where the normal high tide line is on a marsh or behind your house or in business, look for where the alternate flora ends, and that'll tell you. You're trying to figure out where the other cue is looking for where the rack, R-A-C-K, all the debris accumulates. All right, and so a lot of that's going to accumulate right there along the low marsh, or a little bit further in. Or if you come out after a storm, you can see where the storm kind of line is, sort of where your upper high tide line is, your instead of wetland line. And because again, you'll see that rack line, just like at the beach, you'll see it after a flooding in a marsh. So, and that's just accumulation of, vegetative debris from the marsh, from the forest, and unfortunately, a lot of litter from humans dropping into the water and being washed around. The other nice thing about this spot is it really gets you into that sort of coastal forest right here at the edge. So you can see, obviously, we have our salt bushes growing right along the edge here. But then we have our loblolly pines we talked about. But the other dominant tree in the kind of really the maritime forest in southeastern Virginia, really it's only in this part of southeastern Virginia, not much further north or west, is live oaks, Quercus virginianus. So live oaks have been here forever. We've got some really old ones, the Willoughby oak, some of the ones down in First Landing. And these trees they're not as salt tolerant as I think people like to think they are. Like you can't plant, like if you go along Mowbray Arch and Dent, you'll see that there's still some live oaks growing along there, but a good number of them are starting to die off and others are in decline. And that's because they're drowning. So they're getting too much salt too regularly, too much water, too much salt too regularly. They're very well adapted to growing in the coastal forest, in the floodplain, where they get salt and flooding during a hurricane or a big nor'easter. So they can handle it 10, 20 times a year. They cannot handle it on a regular basis, day after day, every month. And that's why those are dying down there. And, we've talked about some other species we can replace them with, things like eastern red cedar, but those block the view shed a little more. So they're probably not going to be real popular along view sheds like Mowbray Arch. But yeah, so these species are important. They're big habitat species. They maintain some openness to the understory. Some other species are adapted to growing in. Unfortunately, very commonly nowadays, English ivy is what is adapted to growing there. But it's an ongoing effort out here, like everywhere else, to control that and other invasives like Vinca minor. but you'll see different species of ferns, again, different wildflowers and grasses. You start to get a lot of like holly species starting to mix in. Yopon holly has high salt tolerance. It will grow right down here along the edge and then up into the floodplain. Your American holly has slightly less salt tolerance, but will grow again just a little bit further inland. A lot of people, I think of that as like a mountainous tree. You know, think winter wonderland. It's a coastal plain tree. Wax myrtle is highly adapted to salt. If you go over on the eastern shore of the Barrier Islands, where I did all my graduate research, just forests of wax myrtle, 20 foot tall, falling over. Really, there's some growing right there. The little guy, right? So they kind of all intermix down here, and so those are some of the really common species. You get into maybe a little maple. Maples have slight salt tolerance. You'll start to see them intermixing and higher up, and they like a little bit wetter. More of our little pines. What else is that here? Those are the kind of the really major ones. As you go a little further south, you have some other species of oaks that start to mix in. A few of the other local native species of oaks will handle some salt. White oaks have a little salt tolerance, but generally speaking, those oaks are going to be deeper into the forest, deeper into the city, away from the coast, and these are going to be our dominant species, or these dominant overstory species are the loblolly pine and the like. Trying to see if there was anything else interesting to show out here. It's like a woolly grass growing still right there. Mixed it with the spartina. We did plant some other grass species at the top here. Okay.
Are they all bent this way because of the wind, or does the tide come up? How far does, like, right at the edge of that, is that where the tide stops, or does it stop at the rock?
So on a normal sort of daily tide, it's going to stop down right at that kind of low dividing line where the taller grasses meet the dropping over grasses. So the two spartinas. But then, during those higher moon tide parts of the month or storm tides, it's going to push on up, and where we're standing here will be underwater.
You find some baby Baruchia here?
I did find a baby Baruchia. I found a baby wax myrtle.
Oh, yeah.
And a
that one
baby Easter red seed, right?
started on its own. But
You find some in here?
we had planted some spot where Robin's standing.
See any Baruchia down there, Robin?
There-
No Baruchia.
No, well, maybe they didn't take too well. We moved them from a spot where they were like really starting to be domineering.
Prunus marittima. Yep.
Maybe they might be underneath some of this grass that's flopping down. Yeah, I'm trying, but it's not doing very well.
Yep.
So
I live in Ocean View, and I went to a nursery and got 3 river roaches.
Okay.
And they were about 6 years old, and all 3 of them died within weeks of each other. It was like really dead. So I went and asked someone what happened to them. They said they found salt.
Mm-hmm.
Who do you ask to find something that you know is going to be able to make it, or how deep is the salt where you live? How do you find these things out?
Oh, you go about the scientific approach. Dig a test hole and test the soil. Yeah, I mean, you generally at the beach, because the sand is so the water table actually slopes down a little bit there from the ocean and then back up. There's a freshwater lens that floats right above the groundwater. But the groundwater near the ocean there is going to have salt in it. And at some point,
So we thought we were pretty safe, but I guess not.
yeah, would depend on where you are. We'd have to take a look at
It's
it.
okay.
But yeah,
I just wondered how if you go shopping and go to invest in a tree, how do you gauge that?
you definitely need to look for guides. Geology Marine Science has guides. You need to look for guides that are specific to coastal settings, because a lot of times nurseries and online websites will talk about salt tolerance, but they're talking about street salt. So salt that you put down up north when
Right.
and it's salt is salt, but there's different amounts of it. There's
I
different
think there's a
how
Virginia
often it's
Tech.
flooding. So street salt gets washed off
Yeah.
as soon as it rains again. And
Yeah.
some gets in the soil, but not to the same extent. But there's some of these species would be like we're talking about here.
Yeah.
River birch does have some salt tolerance,
Right.
but
Yeah.
I don't know that his
Justin.
explanation is quite true.
There, actually, Virginia Tech has a
Virginia
publication.
Tech does have a good publication.
Yeah.
But that one does say salt tarts, and it is.
Is it street salt?
It's just salt in general.
Salt in general.
Yeah.
Yeah.
Be careful a little bit of that.
Okay.
So I live 2 streets up from the Lafayette River. The groundwater that's spurted through my basement last weekend, is that salt water from the river or is coming
If
fresh
it was coming
water
from
from the
groundwater,
ground?
that should be fresh.
Oh, okay. How
Yeah.
could I think?
Because when the salt from the ocean and the river water does get into the groundwater, but it's like a curve. It comes in and then it goes down and then it gets stopped by the freshwater lens in the ground table. Some complicated physical chemical processes for why it stops infiltrating in. It is something we're increasingly having problems with. We're getting saltwater intrusion into our groundwater table everywhere along the coast. So it is a problem that we're having to deal with more and more. But
So
around
can you
here,
put
we
it out?
a well should be fine because you're going to go in. A well would go into a deep rock. It's going to definitely be fresh water. Yeah. It's when you're real close to the coast and you get into that shallow ground where it could be salty. But generally speaking, around here, we don't have that problem quite yet. But one more thing we'll be dealing with in the future, and that's one I can't fix with walls and buckets. That's one that's just going to happen. All right. No.
No.
Magnolia grandiflora is native a bit further south from here. If you get down to Charleston, Savannah,
Yeah.
live oaks are still native there too, but you definitely get more of that mixed in. That does not have quite as tall. I keep forgetting this microphone's on me. Can I flip it around?
Yeah.
I'm fidgeting.
Yeah. No.
That you would find that in the coastal plain, but it would not be right down here.
It was pulled out.
Let's keep walking. We have a little walkway down here. We can walk along, get over the marsh a bit more, and we'll be wrapping up and going inside. So this area here was actually some of the earlier restorations at the Hermitage, maybe 15, 18 years ago. There's a wall out here, which we'll see as we wrap up, but they wanted to protect that and sort of the eroding land. I'll show you some cool pictures of what used to be out here. But so they put a little low sill out here, backfill sand. That was all done with volunteers. So some of this work can be done not always with big equipment, but a lot of times with volunteers too. And over time, they worked with different groups like Chesapeake Foundation to add oyster balls, which I think we still have an example of up here, right? Or a little sign.
Yeah.
And that created some more barrier. Created this little spit that's forming out here, and it's almost like a little salt pond in here. I think historically this was like a swimming hole.
Yeah.
At the Hermitage. Yep. So it was closed in, and it had
Like 80 years ago.
Yeah.
Or more. Or more.
they used it
100
as
years ago.
yeah.
100 years
an old building. But again, you get up closer, you can see the oysters growing out there on the mud line. Again, starting to build up, layer up on top of each other. Very healthy marsh in here that sustained itself over time. So we're standing over the low marsh right now. So you can see it's all the more upright Spartina alternate flora that gets flooded on a regular basis. Then we get into the saltbush thickets. And you may have seen as we walked around the wet area in the middle there along the path on our left. That's a good example of a floodplain. So not everything's going to look like wide open marsh like this. A lot of it's going to have trees above, but it's still going to be wet and mucky. Yeah, more of what you would think about a marsh, probably historically. And that's just got salt bush growing in there. And there's some other species. That's where you start getting into some of your Yopon hollies, your American hollies will grow in those sort of shadier areas where the grasses cannot grow. A lot of people ask why the grasses aren't growing like along some of our parks and stuff, because they get shaded out. Most grasses are not adapted to shade. Most grasses want full sun. That's why our front yards have these, bright green grasses are adapted to all that sun. And the marsh grasses are the same way because in their natural setting, nice wide marshes, they get plenty of sun. We just need to plant that. We're trying some different things to see if we can find some species that are a little better adapted to it, but it is hard. Chunkus may be the one. As you look down here on the marsh, on our mud flats, can't see if we see any little snails, but there's some little periwinkles crawling along some grasses. A few scattered in there. If you look closely, you'll see little bubbles. You'll see the worms coming up out of the mud. Little crabs. You come out here in the summertime, you fiddler crabs. Periwinkles everywhere. To the point where they weigh down the grass sometimes. Obviously, lots of bird species use this. I don't see anything particularly interesting today. But sometimes we get cool stuff out here on this tour.
Several types of herons,
Yeah.
you know.
Lots of herons
Yeah,
in the
nice.
marsh waiting around. Obviously the little baby fish forage through here in the breeding season. So the marsh that we created ties right into this older marsh just down here past this big pine tree. So we meshed it all together so that we restored what historically was all marsh all throughout this cove, and this cove went deeper into the neighborhood as a little creek. It wasn't always a cove. This was all bulkheaded. The Hermitage shoreline, I don't think was ever bulkheaded.
Just the end.
Just the end out here, yeah. So that was always natural, but eroding. So we took it all the way from the end of the road over there, wrapped it around, and tied in here. This has been restored. So really, it's a nice long section of restoration over several different projects that I think is, turned out pretty well. It's what I always point to. It's nice. It's very visible. You can see along that stretch there, and it really looks pretty nice along here. It's very healthy. Herbert is doing a great job of managing it. I was looking for some Phragmites. I don't see any because I think you killed it all.
I hit it,
I'm sure there's some somewhere. It always comes.
No, there's always a little bit here and there.
Yeah,
Content with.
That Phragmites australis is it's a invasive. There is a native species technically, but it's almost gone. So it's intermixed, hybridized with the non-native to the point it's kind of like cattails, to the point where they're indistinguishable, except to super scientists and botanists. And basically, what it is. Phragmites causes problems, chokes out our native plants. I have some pictures of it, if nothing else. But it gets really tall, blocks views, chokes out. It is good at accumulating sediment, so it actually does keep up the sea level rise. So there's one benefit to it. But other than that, it doesn't provide much food source. It's just not a good species. So in the marsh we don't have too many invasive species, but that is unfortunately one that in the high marsh it will definitely take over. I'm sure you've all seen it. It's everywhere.
Like shade.
Doesn't
mind
shade, so
Doesn't mind dry.
it takes salt or fresh water. It's a truly bad invasive species. It goes everywhere. I think there's a little sign up here that shows these oyster balls, and I'll show you a few more pictures. But the other thing is, instead of the rock, we have been starting to work with different types of materials. So, rock granite is not native to this area either. Granite's out west. So we try to find different things. If you get down to the beach, more like calcium-based, rocks, so coquina, things like that. So there's a lot of different experimenting with different materials, different shapes to get more porosity in the rock to have more of that three-dimensional reef structure right away. So we're trying all these different techniques with that exterior sill to see if we can really get more of those oysters and barnacles and things growing on them. So here's a sign up here. We'll wrap it up there, and then I think we're going over to art, right? Yeah. So let's walk up here and check that out.
Yeah.
So just a couple things down at this location. This is the wall I was talking about a few minutes ago. That the Hermitage, historical wall you did. So they wanted to save, and the marsh was restored out here. It's a nice view. You can see the end of the rock sill, how it just goes right down in the water, and then it's back up on the other side. Well, what's going on here is they left a gap, and we obviously want to make sure that we keep good flushing onto the wetland so that any fish are in there get back out. It's good kind of flushing. And the earlier science on this, they wanted bigger gaps. This is a big gap for a living shoreline project. And what's happening is behind that gap, you can see that it's carved out, basically a fan here. And so that it's relatively stable. We've kept an eye on it over the years, but ultimately we will probably eventually have to close that gap up a little bit, backfill some sand in there with some wheelbarrows or barge or something, and we kind of enhance this previous project because it will keep slowly eroding back because you do get some wind through here, some waves wrap around from that side, and that gap's just a little bit big. So I'll show you a slide in there that talks about gaps a little bit more, but they're important, but you've got to make sure the size is right where you end up with situations like this. It's the exact same thing that happens at the beach when you have the breakwaters out there and then you see the beach doing these scouts and things. Same thing happens at the beach. Same thing happens on the marsh. All right, it's all just hydrodynamics and sand movement. So, but otherwise, doing good out here. The wall's protected. I wanted y'all just as you're walking by, the sign over here showed one of those kind of more modular techniques of these oyster balls, which are big concrete, so they're still not a native material, but big concrete balls. But they've got tons of space inside, so the oysters can grow on top and on the bottom and on the inside. And it really helps to create that three-dimensional nature of the reef faster. They were one of the first Chesapeake Bay Foundation started using those years ago, and that was one of the first of the types. But now, some of you may have or may soon go work at a project somewhere that uses oyster castles, which are like little Legos that you can place along the shore. There's some others that are made out of some of that more calcium-based materials they're using down in Carolina that we're going to test out of here. They're going to have to be placed by machinery, but they're going to be long linear sections that you can place. We're just trying different things. We got somebody 3D print out of materials, and they're even starting to put dredge spoils in there. I don't know. What's that? Dredge spoils, so like muck and mud and stuff. So, a lot of science going into how to more creatively restore weapons. But at the end of the day, if you put some sort of a hard structure in some sand and plant it, and you have the slopes right, you get more stable shoreline. We're going to talk a lot more about that as we go inside. Bill, anybody, anything else we want to see outside here?
We might be able to get a view of some oyster balls
Yeah, maybe
over
see
here.
the top of some oyster balls out here. The city restored a 5-acre oyster reef right off the front of the Hermitage. The Army Corps, the Port, ERP, CBF have restored another 30 acres right, just over here off the edge of the port. So it's a lot of oyster activity going on right off front here. So we can walk by and see if we can see anything. We'll walk too close to the edge. The edge's getting a little dicey. It's still one of these days I'm gonna figure out a way to make that project work.
Yeah. Well, we have a Band-Aid project happening in the next month or so to fill our craters.
Okay.
Yeah. It's sad, but that's all.
Get it ready for wedding season.
See him, Sally? Yeah.
Yep. Oysters, some articles, and you got some macroalgae growing on. Yeah.
So do the castles do about like this, or is it?
They do. Yeah. The castles are placed closer to shore, so they're not going to get oysters quite that thick that fast because they're more intertidal. These are mostly during a really low tide, they'll get
I was volunteering over in Colony Point, putting the castles in, but there were already these black mussels in the grasses.
Yep.
Are those not as useful as?
Yeah, the mussels are important. But they really hope to hold the marsh together.
That's what he said.
Implement how to introduce those fast.
Yeah.
So they'll come in naturally if there's a nearby marsh, but if we could get them in quicker, then it would really help to stabilize.
It seemed like they were holding on to the roots.
Yep.
Everybody see the oyster balls out here?
So as you walk down this way, you can see the oyster castles out here. You can see they're all covered with oysters pointing every direction. Got barnacles on there. Some macroalgae. The green you see is macroalgae that are an important part of the food web out here as well.
It's okay. Go ahead.
I've
Just past that, you can't see it, but that's where there's a big oyster reef that extends out where these coasts are out here. So that's all oyster reef out there. Then all the other little coasts you see out here.
For me, I don't care. I'm taking the day off.
Don't bring your boat over.
Oh, okay.
A little dicey. Good fishing. People like to fish out here. All these oyster reefs bring a lot of fish in. No, the question, you cannot eat the oysters in the Lafayette River. The Lafayette is still closed for harvest. Probably wouldn't kill you. It would potentially make you sick though if you eat the wrong oyster. We have a wastewater treatment plant right there that they're not dumping sewage in the river, but they're treating water to an extent. And then there's lots of other. There's still some septic systems on the Lafayette, not many, but there's a few. Stuff happens. So don't eat the oysters in Lafayette right now.
And where did you say the oysters?
That right here. Right here. Yep.
Do they test for good now?
There's some scientists in the health department now.
Do that, yeah.
Yeah, and some folks. don't get to any report for that stuff unless there's a big issue. But you know, as long as they're healthy, they can fight off some of that stuff. Okay, keep walking.
I think are we finished?
Yeah, we're pretty much finished out here.
So we'll should head back to the VAS.
Yep.